Okie dokie. So this is where we get to use our knowledge and understanding of the unit circle to graph y equals cosine x. On the next slide, we'll graph y equals sine x, and we start with the basic trig functions, just cosine of x and sine of x, and we're sort of moving towards being able to graph all kinds of trigonometric functions. So that's what this unit is about. And let's begin by thinking about an angle that starts here at 0 degrees. And I'm going to sort of interchangeably talk about radians and degrees because we know about both and it's important to keep our minds fresh. So we start with an angle of 0 degrees. And we know that the angle, as the angle increases, this line kind of rotates around. So after it has rotated through 90 degrees, it will be right here, or pi over 2 radians. And then after it has rotated through 180 degrees, it will be here. So this angle is rotating like this and like this. And it keeps going, and it keeps going, and it keeps going, and it keeps going. We can also talk about negative angles, where it starts here and then moves in this direction. So that would be a negative angle. So when we're graphing y equals cosine x, x is the angle, and y is the value of the cosine of that angle. So we will think about the unit circle. We're going to fill in values on the, or in an xy table, and we will plot the points on this graph, and we'll see that it looks like this cool, like ocean waves type thing. So when our angle, when our angle is 0, hey, what's going on? Let's we'll go with an arrow today. All right, when our angle is 0, the value of cosine of 0 is 1. So we could put a value in here. So when our angle is 0, and let's use degrees just to keep it simple for a little bit. And so these are the degrees, and this is the value of cosine of the angle. We know that the value of cosine is 1. Okay. So take a look or think about, as the angle increases up to 90 degrees, what happens to the value of cosine? So I'll draw a couple. So when the angle is right here, cosine is the x-coordinate, and it would be like that. When our angle is here, cosine is the x-coordinate, and it would be like that. So it's going from 1 down to 0. It's getting smaller. When our angle is really close to 90, our value of cosine would be just a little tiny bit. And when our angle is right here at 90 degrees, our value for cosine would be 0. Again, it's the x-coordinate of that point. So I think we're familiar enough with that that's going to make sense. So we could say, this is going to get a little messy, but who cares, 90 degrees, and our value for cosine would be 0. Okay, now we haven't started graphing it yet, but let's think about when our angle goes more than 90 degrees, our value of cosine is over here. So let's take an angle like that, and that would be our cosine. I think I switched the blue and red there, but you got it. So here's our angle and our value for cosine, and then as our angle increases, right, our value for cosine is getting closer and closer to -1, which it attains, meaning gets to, when the angle is 180 degrees. So we could say at 180 degrees, our value for cosine is -1. So we're talking about that point right there. And then we can continue thinking about this. So as the angle increases all the way to 270, our value for cosine goes from -1 to 0. So again, you're picturing this angle, and you're thinking about the value of cosine, and as the angle increases, the value of cosine decreases, and it's getting, so there's our angle, and this is going to get real messy, and it approaches 0. So let's get rid of all that stuff. So once the angle gets to 270, our value for cosine of the angle is 0. And then the angle increases even more, all the way to 360, and by the time it gets to 360, our value for cosine is 1. So 360, and our value is 1. So let's zoom in. Notice how we were only talking about positive angles, so we'll just look at this for now. keep it simple. So we have 0 degrees, 90 degrees, and these are normally appropriate values to put on the x-axis. 180 degrees, 270, 360, and if we went another, so here's 360, if we went another 90, so 360 plus 90 would give us 450 degrees. Let's get rid of that stuff. So up here, 450 degrees. And just so we don't forget about our radians, our good friends the radians, this is pi over 2, or 1/2 pi. This is 1 pi. This is 3/2 pi. 2 pi. And then this would be 5/2 pi. So you see the pattern. 0, pi, 2 pi, 1/2, 2/2, 3/2, 4/2, 5/2 pi. Okay, and our values for cosine of the angle, at 0 degrees it was 1, at 90 degrees it was 0, 180 degrees it was -1. So we have these values here on the y-axis, 1 and -1. So I'm going to say something of great importance right now. The value of sine or cosine of an angle will always be between 1 and -1. I will repeat the value of sine or cosine of an angle will always be between 1 and -1. So that'll come up again, and I will repeat it again. But if we were to plot our points, they would look like this. And if we were to graph, we would have this beautiful, smooth, flowing, sinusoidal, sinusoidal graph. So this is a word that describes this oscillating, smooth curves, looks like ocean waves. Graphs of sine or cosine. And, this is called sine, not sin. I'm hearing a lot of sinning in class. I'm not feeling it. So, let's talk about a couple more values. So if we were talking about negative angles, like what happens over here? Is the graph blank? Nope. Negative angles. So if this went in this direction, by the time, so cosine starts at 1, right? By the time we get to -90 degrees, the value of cosine would be 0. Again, remember this is 0, -1. Value of cosine, the x-coordinate, would be 0. So we could put in a couple more values here, like -90. We're going to keep going the other direction. At -90, value of cosine is 0. And if we continued in the clockwise direction, by the time we got to -180, we would have that the cosine is -1. Again, coordinates of this point, -1, 0. So, what are we doing? This and this. So -270 would be -90, -180, -270, all the way up there, has an x-coordinate of 0, 0, 1, but you knew that. So, if we plotted these points, let's zoom into our negative zone here. At -90 degrees, the value of cosine is 0, and at -180, so this is -90, -180, -270. When is he going to stop talking? Soon, don't worry. Okay, -180, we have a value of -1. At -270 degrees, we have a value of 0. And so you see this pattern, right? You plot a couple points, you know, oh, it's going to do this. You can always think about it to check, but yes, the value of cosine of -360 degrees is 1. You could check on the unit circle, ask the calculator, ask the person next to you. They will all agree. So this keeps going. And there we have a beautiful graph of y equals cosine of x. Yeah. And we just thought about what happens to our value of cosine as the angle rotates in the positive or negative direction. And we plotted points and we connected it with this nice smooth, not like straight lines, nice smooth ocean wave-like curves. Whoop-de-doos. Who knows? Alright, I think we got a couple more minutes. We're going to take a look at y equals sine of x. You might want to, you might want to pause and Flip over your notes and take a look at y equals sine of x and see if you can actually graph it. You could use pencil just in case you make a mistake, which you probably won't, but or you could just take the path of least resistance and watch me solve it. Shame on you. Alright, so here is y equals sine of x. Probably you were good kids, serious students, and you put that on pause and you already tried this, and you probably got it right. So, 0 degrees, right? This is where we're starting, and we're going to talk about positive angles, and I'm going to go a little more quickly. It's the exact same thing that we did, but, you know, sine of x has different values from cosine of x. At 0 degrees, the value for sine is 0. Again, sine is y-coordinate of that point, which is 0. So we got 0, and we got 0. And we're going to use the same values. 90, 180, 270, 360, and then we'll do some negative values as well. Ooh, that's not an 18. No way. Okay. So, 90 degrees, the sine is 1. Don't believe me? Check it out. 0, 270, negative 1, and then 360 back to 0. Yeah, so I know that was quick. Y-coordinate is 1, y-coordinate is 0, y-coordinate is negative 1, y-coordinate is 0. Yep. And then we're talking about negative angles like this. We're starting, y-coordinate is 0, y-coordinate is negative 1. Whoa, that's a negative 1 right there, even though it doesn't look like it. Negative 1, y-coordinate is 0. Y-coordinate is 1, and you can guess, right, the pattern. Y-coordinate is 0. Okay, so let's plot some points, or the values on our axis. I could repeat that important statement again. Sine and cosine have values that are always between 1 and negative 1. So, like 1.1? Nope, never. Alright. So what were our values? We had 0, 0. It's hard to see our table, but it's right in front of you, so we're all good. 90, 180, negative 90, negative 180, and you're wondering, what are those in radians? Yes, we know this. Pi over 2, pi. Negative pi over 2, negative pi. Okay, where were we? Oh yeah, 0, 0. And then by the time we get here, our value was 1, and then 0, and then let's make some space. At 270, the value of sine was negative 1, and at 360, the value was 0. Again, that's correct, yes. 3 halves pi, 2 pi. This one over here, what was that, 450, right? And 5 halves pi. And then that would be up at 1. Yep, I believe it. Okay, so this side of the graph looks like... And I don't know, you can make sound effects. So this looks a whole lot like cosine. Actually, I'll wait until we have these. That'll be the grand finale. I'm pumped. Okay, so real quick before we run out of time, negative 270, 360, and our values were... Hey... Put that in the right spot. The values were negative 1 and 0 and 1 and 0, and our graph, nice smooth flowing curve, ocean wave. You can forget about that little typo right there. So this is the graph of y equals sine x. It looks a whole lot like y equals cosine x. Y equals cosine x. I'm going to superimpose here. Let's just make sure we know what we're talking about. In blue, y equals sine x. In orange, how did it go? Yeah, just like that. So, do you see how the blue graph is just like the orange graph? This orange graph, this would be y equals cos x, which we just took a look at. But it has been shifted by 90 degrees. So it's like you take the orange graph and you just move it to the side by 90 degrees, and all of a sudden it is the blue graph. Yeah.